Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and I am glad that you are here. Today, we'll be solving LeetCode problem number 107, Binary Tree Level Order Traversal 2. Given a binary tree, return the bottom-up level order traversal of its nodes' values, i.e. from left to right, level by level, from leaf to root. For example, given binary tree, and then we have this tree over here, return its bottom-up level traversal as 15, 7, 9, 20, and 3. Now, let's see why that is. So, we return the rows from bottom to up. So we have 15, 7, which is the bottom row, so it's going to be on top. Then 9, 20, which is the middle row, so it's going to be here, and 3, which is here. And we have to note that these rows go from left to right, so we have to keep that in mind. Now, we can solve this problem with recursion. If we iterate over each row, we can see that we can either add it to an existing row or create a new row with that element. So to do that, we need to create another recursive helper method that takes in the root, a list of integers, and a number for the row. So let's first initialize our original list. Let's just call it tree equals new array list integer list of integer, and then parentheses 7. Now let's call this helper method lob for short of level order bottom. So return lob of, and now we want to use 3 parameters: root, the tree node root, the array list, the list of lists tree, and the number of row. So in this case, it's 1. Now let's create our helper method. So public list of integer, and then lob is, and it takes in 3 parameters: tree node root, list integer prev tree, so that we're going to take the tree before modification, and int row none. Now, before we use our recursion, we first have to modify the tree. So let's first check if the current node is null. So if root equals null, then return prev tree. Now otherwise, we can first initialize this new row. So we first check if num row is greater than prev tree.size. And since we're going to be using the size method a lot, let's just create an integer that stores the value, equals prev tree.size. So now that we have our size, we first check if the number of row is greater than the size. And this basically means that it's checking whether or not this row has been initialized in the list. If it hasn't been, then we need to add the row. So let's first create another list integer this time, and then it'll be the cur row in the tree equals, and then we don't need to initialize it yet. So now if num row is equal to greater than size, then we have cur row. Let's just initialize it. List integer, then we need array list integer. So now we add the value of the current root, which is root.val, and then we add cur row to the beginning of prev tree. So prev tree.add, and then to add at the beginning, we can pass the location in as a first parameter. So that's 0, comma, and then we want to add cur row. Otherwise, if the row is already included, then we should modify that row. So cur row equals prev tree dot get, and then we want to get so row number 2 is the beginning, so it's going to be 0 plus, and then we have the size minus the number of rows. So in this case, the size is 3 and num_row is 3, we're going to get index 0. So size minus row num. So now we remove the value at this index, and we add. We also want to add to per row dot add and root dot val, and then prevtree dot remove, and then this index, and now prevtree dot add, same index, but now we're going to add per row. And now that we're done modifying the current tree, we can now use our recursion. So we need to check if the root has left, right, both, or neither nodes. So let's create another helper method. So public int, because since we have more than 2 possibilities, we need more than just a boolean. So let's just call this method left, right, and then we take in a tree node, root. Now we first check if, since we're basically given that the root is not null since we already checked for it, we first check if root dot left and root dot right are null. So root dot left equals null, and root dot right is null. In this case, we return 0, because let's just let 0 be if both are null. And now we check if root dot left is null. Now, since we know that both are not null, if this condition is satisfied, that means that root dot right is not null. So we can return 1. And similarly, we can do this for root dot right. And this means that root dot left is not null, so we return 2. And then finally, if it's none of these, that means it has both left and right, so return. So now let's check what this is. So let's create an int, and let's call it, we're going to call it left, right, nodes equals left, right of root. So if nodes is equal to 0, then we just return the current one, tree. So return prev tree. And then if nodes is equal to 1, well, if nodes is equal to 1, that means that we only have to check root dot right, since root dot left is null. So we return lob of, and then what do we have? We have root dot right this time instead of just root, and then we also have prev tree, and now row num plus 1 instead of row. So similarly, if nodes is equal to 2, we use the same thing except return root dot left. Now finally, we check if nodes equals 3, and if nodes is equal to 3, we have to add both the left and the right nodes. However, since we go from left to right, we have to use the left first. And this is simple. If we just return lob of, so we have root dot right, but then we also have lob of root dot left. And this ensures that we calculate root dot left first. And then prev tree, row num plus 1, and here we just add one more 1. And now this should be comma row num plus 1. And this should be it, because we iterate over every row and add to the array. So if we run our code, oh wait, one more thing. So yeah, first we didn't do that. Second of all, we used nodes instead of left-right nodes. So just copy this. Okay. So now when we run the code, it should work. Cannot find this. Oh yeah, I use num rows. So run them. Alright, so that should fix all the compilers. And we're accepted for 1, 2. And if we use the original input, which is right here, we can first visualize the tree, see that it looks like this tree right here. So we should get 15, 7, 9, 23. And when we run code, we indeed get just that. Now let's just try one more node, except everything's filled. So let's just put random numbers. Okay, so now if we check here, we have another tree that looks like this. And if we run our code, it is accepted. So now we can submit. And we see that our runtime is 2 milliseconds. Our memory usage is 39.7 megabytes, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at steamaspirations@gmail.com. Once again, this is Vishnu Manjapudi signing off. Bye.